Dear student, today I am going to cover the classification of antihistaminic agent on the basis of its chemical nature or chemical composition. These agents are also known by the name H1-receptor antagonist or classical antihistaminics or conventional antihistaminics. These agents usually act during histamine release in our body, and histamine is usually released during allergic reaction. That's why this is also known by the name anti-allergic agents. The before going deep into this classification, we have to memorize that all the antihistaminic or most of the antihistaminic agents have this tertiary amine group. Tertiary amine group in its structure. This group is common to most of the antihistaminic agents. The first class of antihistaminic agents is ethanolamine or amino-alkyl ether, and the drugs which comes under this class is diphenhydramine. Diphenhydramine. Now, from this name, we can draw a conclusion that these drugs have diphen means two phenyl rings. Di means two, and phen means phenyl. Two phenyl moiety means the class of drugs is ethanolamines or amino-alkyl ether, and these drugs have two phenyl rings. So first of all, we will draw ethanolamines. Ethanolamines means CH2. Suppose this is your ethanol, and amine, as I have already discussed, amines means tertiary. Most of the antihistaminic agent have this tertiary amine groups in its structure. So this is your tertiary amine groups. So this is ethanol amine, and the drugs which comes under this class is diphenhydramine. Diphenhydramines means how we can draw the structure of diphenhydramines. So before drawing diphenyl or before adding or putting diphenyl group, we have to focus on this structure, amino-alkyl ethers. So this is amino-alkyl group, and ether have another R moiety, ROR. Ether have the functional group ROR, functional structure. So R, this part is R, this is oxygen, so here is another R, so another R is there, here only CH group is there, CH. Now diphen means two phenyl, so there are two phenyl moiety. This is first and this is your second. This is the structure of diphenhydramine. Now the second class which comes under antihistaminic agents is ethylene diamine derivative. Ethylene diamine derivative. Now the example of drugs which comes under this class is mepyramine. Now before drawing the structure of mepyramine, we have to focus on this name, ethylene diamine. So how we can draw ethylene diamine? So this is your ethylene moiety. Diamines means two amine, and I have already discussed most of the antihistaminics have this tertiary amine groups. So this one is your tertiary amine. Ethylene diamine. This is ethylene. This is diamine. Ethylene diamine. Now mepyramine. Mepyramine means we can draw a conclusion from this name. Me means methyl. Pyra means somehow some aromatic functionalities is there. So how we can draw this methylene pyramine functionality? So you have to memorize only this, that there are one pyridine moiety, and there is one methyl group or methylene group, and then again there is an aromatic nucleus here, and this aromatic nucleus have again methoxy group OCH3. So these two are methyl, and these two are pyra group. Pyra means aromatic nucleus. So no need to mug up the structure. We can draw a conclusion of the pyramine from its class and its name itself. So this is your pyramine. Now the third class, the third category of drugs which comes under this class is alkyl amine derivative. Alkyl amine derivative. Now again, alkyl amine derivative have an best example, that is phenyramine. And one more, chlorphenyramine. So again here the name of class is alkyl amine. Alkyl amine. Alkyl amine means somehow some alkyl moiety is there and amine is always tertiary amine. So which alkyl? So here propyl, 3 carbon moiety, CH, CH2, CH2. This is your alkyl, and which alkyl? Propyl. Okay, and as usual always there is tertiary amine. So this is your tertiary amine. Alkyl amine derivative, and the example comes under this class is phenyramine. Phenyramines means this name also have phen. Phen means phenyl. So usually there are again 2 phenyl moieties, and one of the phenyl moiety is there again the same. One of the phenyl moiety is again as usual, as we have already draw the structure. One of the phenyl aromatic ring is your pyridine, and the second one is your phenyl. So this is your phenyramine. Phenyramines means phenyl and pyridyl. Phenyl and pyridyl. This is your phenyl ring and this is your pyridyl ring. Now the second example of this class is chlorphenyramine. So chlorphenyramine have only chlorine moiety, and the chlorine moiety is usually present over here at 4th position. So this is your chlorphenyramine. If chlorine is removed, then it is phenyramine, and if chlorine is added over here at 4th position, then it is chlorphenyramine. So this is your class number 3rd. Now the class number 4. Class number 4 is phenothiazine derivative. Phenothiazine derivative. Now, what is phenothiazine? I have already discussed the structure and their numbering of this phenothiazine ring in my third lecture of the structure of your aromatic heterocycles. In the previous lecture, I have covered the structure of phenothiazine. So, phenothiazine derivative include, or this category of drugs, the drugs which included under this category is your very famous promethazine. Promethazine is the active ingredient of Avomine. Avomine is an anti-vomiting tablet which is available in the market. Avomine, promethazine. So now, how to draw the structure of promethazine? So this promethazine comes under the class phenothiazine. So first of all, we have to draw the structure of phenothiazine. So this is your phenothiazine. This is your phenothiazine, and the numbering of phenothiazine begins from this position 1, 2, 3, 4. This is already I have covered in my third lecture. Now, phenothiazine have the example of promethazine. Promethazine means somehow there is pro. There is 3 carbon structure. Main means methyl group is also there. So 3 carbon structure means how we can draw. So 3 carbon means this is you have to memorize. The first carbon CH2, the second carbon CH, and the third carbon CH3. And again, as usual, this antihistaminic class have tertiary amine groups. So here comes your tertiary amine group CH3, CH3. So this is the structure of what? Promethazine. This is the class number 4. Now class number 5. Class number 5 is piperazine derivative. Piperazine derivatives. And the drugs which included under piperazine derivative is cyclizine and chlorcyclizine. Cyclizine and chlorcyclizine. So how we can draw the structure of cyclizine and chlorcyclizine? So this is the class of piperazine. This drug comes under the class piperazine. So first of all, we have to draw the structure of piperazine. And what is the structure of piperazine? I have already discussed, or I have already covered this portion in my second lecture. This is your piperazine, and most of the time we have tertiary amine groups. So this nitrogen is tertiary, CH3. This is your piperazine. And piperazine include cyclizine moiety. So cyclizine means there are some cycles. So which cycle? Cycle means here again phenyl moiety. So how we can draw phenyl moiety? So this is very easy. If you want to draw or add 2 phenyl moiety, then you have to add CH over here, and this is your first phenyl and this is your second phenyl. So in this way, this is your cyclizine. This is your cyclizine. Now if you want to make chlorcyclizine, So what is the structure of chlorocyclism? So chlor means another chlorine molecule. So chlorine, where chlorine molecule is present? So chlorine molecule is present over here. So this is your chlorocyclism. This is what? Your chlorocyclism. So this is class number 5th. Now the last class of antihistaminic agent is your miscellaneous agent. Miscellaneous agent, and the best drug which comes under this class is cyproheptadine. Cyproheptadine. So cyproheptadine, this is the best example of drugs, cyproheptadine. How to draw the structure of cyproheptadine? So this you have to mug up as it is. The only information we get from this structure is cy. Cy means cyclic structure. Pro means 3 carbon moiety, and hepta means 7 carbon moiety. Only this information we get from this name. Cypro means cyclic, pro means 3 carbon, and hepta means 7 carbon moiety. So how we can draw the structure of cyproheptadine? So first of all, this is purely a cyclic structure. There are 2 cycles. First one is this, and second one is this. Now we have to draw a hepta. Hepta means heptacyclic structure, 7 carbon species. So here comes your hepta. 1, 2, 3, 4, 5, 6 and 7. This is your heptacyclic ring. Heptacyclic. Now you have to memorize only this, that this heptacyclic ring is attached to a pyridyl nucleus over here, and you know always this terminal nitrogen is tertiary. So here again SCH3. Now heptadine, dene means diene. So this is your first ene and the second ene is this. So there are cyproheptadine means 2 ene moieties are there. So this is first ene and this is your second ene. So in this way you have to memorize the structure of cyproheptadine. So this finishes your antihistaminic agent, classification of antihistaminic agent on the basis of its chemical composition. Now in the next lecture I will cover the SAR and further synthesis of some important antihistaminic drugs which is important as per your PCI syllabus. Thank you.